तो isotherm is the line joining places having same temperature. करेक्ट. अब प्लेसेस हैविंग सेम टेम्परेचर, यहां एक क्लिक है जो पेपर के लिए बहुत इंपॉर्टेंट हो जाएगा. अगर आइसोथर्म की डेफिनेशन आपको एक स्टेटमेंट में दे, आस्क आइसोथर्म डेफिनेशन, डेफिनेशन वुड बी वेरी स्ट्रेट फॉरवर्ड, line joining places having same temperature. But for the purpose of study and uniformity, what we do is we reduce all the place to mean sea level. Why so? Because every place at different altitude now will give a lot of variation. Even at the same latitude, places have at different altitude will start giving me a lot of variation in temperature, which will make the study very complex. So all the places are assumed to be at sea level, and then isotherms are drawn. So the definition of isotherm में क्या वो click है? That is when reduced to mean sea level. Every place should be reduced to mean sea level, and then isotherm should be drawn. Everyone okay with this, or anyone has to ask anything? What I just said. Feel free to ask. Okay, I'm going fast because definitely we are revising. Anyone? No. चलिए, तो आइसोथर्म की डेफिनेशन में बेसिक आइडिया इज रिड्यूसिंग एवरी प्लेस टू मीन. हाँ हाँ पारितोष, देखिए मीन सी लेवल रिडक्शन का मतलब क्या होता है. सपोज दिस इज अ प्लेस. ओके, ऑब्वियसली इट्स अ हिल स्टेशन नाउ, एंड this hill station, the temperature is 5 degrees Celsius, and its height is, let's say, 3 kilometers. When I say that this place has a temperature of 5 degrees Celsius, I'll not use this temperature to draw the isotherm. Rather, what I'll do is I'll bring this place down to here. This is mean sea level. How will I reduce it? Using normal lapse rate. पारितोष बताइए, यहां से यहां तक, from between P and Q, how much should be the temperature change?
Sir?
Between P and Q, how much should be the temperature change? Anyone else? Anusha?
19.5.
Manoj, okay, Manoj is saying 19.5. And perfectly correct, 6.5 for every kilometer. This is 3 kilometer. So the difference delta should be 19.5 degrees Celsius. If I bring this P to Q, I should add or subtract this value.
P to Q adds.
Add. Coming down, adding, because you go up, temperature decreases. You come down, temperature increases. So then the value of temperature at this place should become 24.5 degrees Celsius. So for drawing isotherm, I'll take the temperature of this place, not 5 degree, but rather 24.5. You will do this for every place, and then you are going to join the places. Paritosh, understood or not?
Yes, sir, slightly I got it.
So every place, let it be at any height, reduce it to mean sea level, and then take the temperature. That is the isotherm. So isotherms, if we see, with respect to isotherm, if I take Earth, isotherm ideally should look like what? Isotherm, I would be, or I should ideally be drawing like this. Why so? Because latitude is the controlling factor for temperature. So if this place P and this place Q is at same latitude, the temperature should be same. And even so, I have negated the impact of altitude. अब तो हमने हर place को we have reduced it to mean sea level. So there is no question of P and Q at different height also. If that is not the case, I should get the temperature at P and Q to be same. That is where the idea that the isotherms should be ideally latitudinal. Okay, so ideal case of isotherm is latitudinal pattern. But along with that, one more important factor comes here, that is land-water differential. क्योंकि अर्थ इज अ नॉन होमोजेनस बॉडी, लैंड भी है वाटर भी है. अब अर्थ तो प्राइमरली कुछ इस तरह का दिख रहा होगा कि यहां पे एक कॉन्टिनेंट है, बाकी ओशियन है. तो देन इट्स नॉट पॉसिबल, अब इस केस में इट्स नॉट पॉसिबल कि पी एंड क्यू टेम्परेचर इज सेम. Even when they are at same latitude, they cannot have same temperature. Why? Because one is over land, one is over water, and we have land-water differential. They heat differently. It is a thermal property of land and water. They heat differently. Getting my point? So I'll have some changes in the isothermal pattern. Now, what would be these changes? Let's try to understand. And these changes, I'm trying to explain it to you logically. Okay, I can give you the relationship directly, but logically try to understand it. क्योंकि यहाँ से this is very important part. What we are doing is isotherm. When you observe, when you study isotherms basically are drawn ideally as a standard for 2 months, January and July, because they will represent summers and winters, 2 seasons. So I can have January isotherm, I can have July isotherm. Okay, everyone. अब देखिए, I am taking January isotherm, everyone. Focus sharply over here. Okay, I want you to understand this part very clearly. I am assuming that there is this land over here. And rest, यहाँ पे हमारे पास ओशियन है, यहाँ ओशियन है. और ऐसे ही सदर्न हेमिस्फीयर, ये हमारा इक्वेटर है, लैंड ओशियन. ठीक है एवरीवन. अब over the ocean I am taking the temperature, let's say over here to be 30, here 25, here 20, यहाँ 15. ये हमने टेम्परेचर ले लिया. ऑब्वियसली टेम्परेचर इज गोइंग टू डिक्रीज एज आई मूव टुवर्ड्स द पोल्स. एग्री एवरीवन. अब अगर टेम्परेचर यहां 30 है तो यहां कितना होना चाहिए? हाउ मच इट शुड बी? 30. हम आइडियल सिनेरियो ले रहे हैं 30. व्हाट शुड बी द टेम्परेचर हियर? 30. व्हाट शुड बी द टेम्परेचर हियर? 30 as well. 30. As of now, all these points that I have marked over here, they all are on water and same latitude, so they will have same temperature. Temperature over here, will that be 30?
No, sir.
नहीं ना, क्योंकि land water differential है. Here it cannot be 30. अब what it should be?
25,
Now
26.
we have learned कि land is heated or cooled more than water. So for this I'll have to look at the season. That's why we have January and July isotherm. January isotherm I am drawing, correct? Northern hemisphere, January is what season?
Winters.
Winters. So land should be warm or cold than water?
Colder.
Colder. So what should be the temperature I should write here? Any
Less
value?
than 30.
Less than
25,
Less than 30. हमने 5 के gap में लिया हुआ है, तो what should I write? Let's say here
25.
25. What should I write over here?
25.
25. चलिए likewise यहाँ करते हैं. ये 25 है. What should be the value here?
20.
Value should be 20 here. Everyone agree to this?
Mm-hmm.
Value should be 20 over here. What should be the value here?
25.
25.
25, 25. करेक्ट. यहाँ क्या करें? 20, 20. Then
15.
15, 15, 20, 20. Agree everyone with these numbers? And
Yes.
likewise 15, 15, 10, 10, 15, 15. बनाया isotherm. Now I have all the values. If I draw the isotherm, what it would look like? 30 का तो corresponding कुछ है नहीं. 25 का बनाते हैं. 25, 25, 25, 25, 25, 25. Correct? Likewise 20, 20, all 20 I am joining. All 15 I am joining. Now can you see the deviation? Now it's not purely latitudinal. Yes. And what can I say? Over land, the isotherms are bending towards north or south? Over
South.
land. Isotherms are bending towards south.
South. In the northern hemisphere.
In the northern hemisphere. January. अब यही काम हम southern hemisphere में कर लेते हैं. Southern hemisphere में करके देखते हैं. फिर से यही ले लेते हैं. 30, 25, 20, 15. So 30, 30. What should I write here?
More
Southern
than
hemisphere
30.
summer. Southern hemisphere January is what?
Summers.
Summer.
Summer. So what should be the value here?
More than
35.
35.
More. 35. 35 correct. तो अब यहाँ 25, 25 so
30.
30, 30, 25, 25. Likewise 20, 20, 25, 25, 20, 20, 15, 15, 20, 20, 15, 15. Everyone agree with this?
Mm-hmm.
And then I'll draw the isotherm. What the isotherm would look like? 30, 30, 30, 30. Yeah. 25, 25, 25, 25. 20, 20, 20, 20. So now what is the case? Over land, the isotherms are bending towards
South.
South.
south. ठीक है? Got it everyone? So towards south bending हो रही है. आप अपने नोट्स में जुलाई के लिए बना के बताइए मुझे. बिल्कुल ऐसे ही करेंगे. वैल्यूज लिखते जाएंगे. Multiple values. So in the July isothermal pattern, what did we got? In the northern hemisphere over land, the isotherms are bending towards
North.
North.
north. In the southern hemisphere, the over land isotherms are bending towards
North.
North.
north. So this is how we can figure out the isothermal bending. Okay, over land I am asking. Over ocean it would be just opposite. Like in this diagram, if I say in northern hemisphere over here, over ocean it is bending towards north. Over land it is bending towards south. So whatever being asked, you can just put these numbers, and based on these numbers you can simply draw the isotherm figure out. So this is the first aspect, that is the bending of the isotherms, how the isotherms bend. ठीक है, everyone got it, understood it? Now it can be asked based on towards equator, towards pole also. I just need this diagram, nothing more than that. It should not take more than half a minute to draw it. And so in this case, what I'll get is over land it is bending towards equator, over ocean it is bending towards pole. Whereas in here, over land it is bending towards
Pole.
and over ocean it is bending towards equator. So north south mein it is very pretty simple. In both the cases it is bending towards south. But this one I'll identify as bending towards equator, this one bending towards pole. Correct? Yes, everyone? So if you want to memorize, just memorize it as January, south bending, over land we are talking about. Over land, January, south, July, north. This is the bending aspect. So now after this property of isotherms, that is the deviation of the isotherms. Let's talk about the next property, which is the spacing between the isotherms. So spacing between the isotherms, if the isotherms are drawn close to each other. So let's take this example wherein I have this particular pattern of isotherm that I find, in which case this is 30 degrees Celsius isotherm, this is 25 degrees Celsius isotherm, this is 20 degrees Celsius isotherm. Now two regions I can see over here. The first region, which is region 1 and region 2. In region 1, these isotherms are closely spaced to each other. And these isotherms closely spaced to each other, what does that mean? It means that with distance, the change in temperature is very rapid. If in this particular region, if you move just from here to here, let's say this is 500 kilometers. So when you have moved for 500 kilometers, the temperature change is how much? 10 degrees Celsius. So yahan 10 degrees Celsius temperature change is there with 500 kilometers. On the other hand, if you talk about the same change in temperature here in region 2, it would be more or less than this distance. It would be more than this distance. This distance now, if you see, okay, this is, let's say, 1200 kilometers. So same change in temperature, but over 1200 kilometers. So it, which means that if the isotherms are closer to each other, then the temperature change with distance is very rapid. Temperature changes very rapidly. Whereas if they are widely spaced, then the temperature change with distance is gradual. This is what we measure with respect to a parameter called as gradient. So over here we have a parameter called as temperature gradient. And gradient simply means change per unit distance. So the formula for temperature gradient, if I have to write, I'll write it as delta T, that is change in temperature per unit distance. That is temperature gradient. So tell me, what should be the temperature gradient over here? Anyone? In region 1, what is the temperature gradient?
Very high and very low in region 2.
Tell me with the number, with the unit.
0.02 Celsius per kilometer.
1 by 50.
0.02.
02, I guess. Yeah, 0.02.
0.02. In the formula, I'll put 10 by 500. 0.02 degrees Celsius per kilometer. Correct? That's the change. Here, what should be the temperature gradient? 10 by 1200. Or to make it simple, let's say I keep it 10 by 2000. Make it 2000 kilometers. So 10 by 2000. 10 by 2000 would mean
0.005.
0.005 degrees Celsius per kilometer. Correct? Which one is more? This one is more. So if you see, I can say that here the temperature gradient is higher. And as the temperature gradient is higher, the temperature change would be rapid. So now if I identify region 1 and region 2, and I have to identify one as land and another as ocean, which one should be land and which one should be ocean?
First one.
Which one should be land and which one?
First should be land. And
Absolutely. Correct. One should be land. One should be land where that, because land responds very quickly to any changes in the insolation. Its specific heat is less. Correct. And therefore, here the temperature changes would be very rapid compared to the ocean. So second property that we have got is spacing of isotherms. And about spacing of isotherms, so what is the idea? The spacing of the isotherms over the land, first of all, spacing between the isotherms will represent temperature gradient. Correct. And second, over land, this temperature gradient would be higher, which means the isotherms would be closely spaced over land, whereas widely spaced over ocean. So this would be your next question in the question list. Now, we can mention isotherms closely spaced over land, isotherms closely spaced over land, and widely spaced over ocean. Widely spaced over ocean. So now we have two properties of isotherms. The first is bending and the second one is spacing. Both of which are a result of land-water differential, a difference in the thermal property of land and water. So everyone understood this concept? Now let us apply it. Very straightforward, simple. Applying it, checking the isothermal maps. So checking the isothermal map over here, if I see the first one, which is this map, represents the isothermal map of January. So January month and the isothermal map. January May, what is the first thing that we have learned? In January, the bending of isotherm over land is towards where? North or south?
South.
South.
Towards south. And let's check this. So if I see this isotherm, check over here, over ocean, and as land comes, it bends here. Yeah, फिर it bends over here. Towards south, it is bending. Similarly, over here, moving like this and bend south. See, southward bending. Southward bending. So correct, in the actual isothermal map, I can see this difference. The deviation, first of all. Second aspect, that is the spacing. Spacing between the isotherm, again check. Here over the land, can I see the isotherms to be crowded? And the same three isotherms over here has spread over here like this. So I can see very clearly over the land it is crowded, closely spaced, whereas over the water it is widely spaced. So that's the difference over here. Similarly, now if I talk about the July isotherm. So taking up July isotherm over here and checking the same things in here. So in here, July isotherm, again what can be seen is primarily where the bending now towards north. Bending towards north, northern hemisphere, in that case it is very prominent. Northern hemisphere, the bending I can see over here. Okay, correct. A little bit of bending is shown over here. So the bendings are the first thing. Apart from that, another aspect related to isotherm that I have to know with respect to spacing and bending is where if I compare the northern hemisphere and southern hemisphere. Northern hemisphere and southern hemisphere, which one has more of land-water differential? Northern hemisphere has more land-water differential, due to which there would be more cases of bending here and there. Whereas in the southern hemisphere, if you see, they are more or less latitudinal only. Especially check these ones, where there is no land at all. It is almost latitudinal. Plus, because it is ocean, widely spaced also. So one generalization I can make, very important for exam, that is in northern hemisphere, isotherms are more irregular and closely spaced when compared to southern hemisphere. Irregular means more bending, more instances of bending. Correct? Southern hemisphere mein, the isotherms are more regular and widely spaced. Got the aspect? So this is again in the question list, probable question list. Note this down. In northern hemisphere, isotherms are more irregular and closely spaced. Isotherms are more irregular and closely spaced. Apart from this, now when we talk about the influence of other factors on the isotherms, here what I would like to do is I would like to superimpose on this, especially for the oceans, I would like to superimpose on this the map of ocean currents. So ocean currents, we will talk about that later also. But as of now, if some prominent ocean current, if I have to draw over here, in this case, there is one ocean current over here, which moves like this, okay, which is Gulf Stream and North Atlantic Drift, which is warm ocean current. Now, if this is warm ocean current, just think of one scenario wherein if I take this up as the same diagrams again, land, ocean. Now, where are warmer isotherms? If this is northern hemisphere, this is equator. So if I draw two isotherms, let's say one isotherm over here, another isotherm over here, which one would be warmer one? This one near the equator. Let's say 30 degrees Celsius, 20 degrees Celsius. Now, if it is January isotherm, let's say, so land is cooled. Over here, water comparatively would be warmer, 35. So possibly I may get 30 over here. And so my isotherm would look like this.
Yes, sir.
Correct, everyone? Now, let's suppose I make the ocean waters warm over here. For any reason, if the ocean waters become warm over here, what will happen to this isotherm? It will shift in what direction?
Upward direction.
Upward. If it becomes warm, possibly this becomes 30. And so this isotherm will reach here up to here. So if the region in the polar region become warmer, the isotherms are going to shift towards that. Correct? And if I make these waters cold somehow, then where will be the isotherm shifting? In this direction. Possibly this one will come over here. So if you make ocean waters warmer over here, the warmer isotherms will reach there. If you make the ocean waters cold over here, the colder isotherm will reach over here. And so this would be the impact here. And that is precisely what I find over here. तो इस केस में देखिए क्या हो रहा है? North Atlantic Drift, Gulf Stream are warm ocean currents. They reach over here making these water warm. And what is the result that I can witness? The result I can witness is this isotherm reaching almost up to here. How come this isotherm, which is in the tropical zone over the land, is reaching up to there in oceans? Due to what? Ocean current. Because ocean current is pushing the warm water up to this zone. So whatever is the temperature over here of oceans, the same is the temperature of land over here. That's the matching. This is due to ocean current. Understood, everyone?
Yes, sir.
So over here, what are the facts that I have to know? Is first of all this hemisphere wise. Second aspect, that is the effect of ocean current. Effect of ocean current. And Next one, this land water differential. Land water differential. Now this land water differential, if I observe again in this map, this is January. And if you see the deflections, the deviation will tell me the land water differential. And the deviation from here to here, this much is the deflection. Correct? So यहाँ हम deflection देख रहे हैं. Whereas in July, if you see, July is summers in northern hemisphere. And now if you check the deflection is only this much. Where do you see more deflection? January or July?
January.
January. So if I ask you, land water contrast is more in January or July?
January.
January, because the deflection is due to land water contrast. So the land water differential is more pronounced in which season then?
Winters.
Winters.
Winters. So season wise, if I see this differential, okay, this is more pronounced in winters, which is very much visible from the isothermal map, comparing these isothermal maps. So in these isothermal maps, what are the things that I am observing? First thing that I can observe from here is hemisphere wise differences. Second, seasonal differences. Seasonal difference, that is in winters, the contrast is more and or less. Then impact of ocean currents, I can very clearly see in these isothermal maps. So this is about this isothermal map. Apart from that, one more thing that I see is the range of temperature. Now this range of temperature, if I check over here, this is the range of temperature between January and July. And where do I find highest range of temperatures? Yes, everyone, highest range of temperature. Where do I find it? You can see it over here. This is the highest range of temperature. Right, northeastern Siberia, around 60 degrees Celsius. So between January and July, how much is the difference between maximum and minimum temperature? Highest over there. Okay, apart from that, now in other areas, if you see encircled areas, 30 degrees Celsius over here, 20 degrees Celsius over here. Okay, these represent nothing but deserts. यहाँ आपका 20 डिग्री सेल्सियस है. Sahara desert, Kalahari desert, Australian desert. And deserts we know have high range of temperature. Deserts heat also too much, becomes cold also too much. But the highest range of temperature you find in Siberia. This is differences in or range of temperature. So everyone understood this concept of isotherm, land water differential, very important concept for the exam. And this is evident from some, in the past few years, the questions that have been asked. Very interesting questions. Let's see whether you are able to figure out or not. The first question that I see over here, this was 2023 question. What is the question reading? This is assertion reasoning type question. The first is statement 1, which reads, the temperature contrast between continents and oceans is greater during summer than in winter. First statement. Second is, specific heat of water is more than that of land surface. It's like assertion reasoning. Both are correct and 2 is correct explanation of 1. Both are correct, 1, but 2 is not correct explanation of 1. Third, 1 is correct, 2 is incorrect statement. And fourth, 1 is incorrect, 2 is correct statement. Tell me the answer.
Option B.
So fourth.
What should be the answer?
The first statement is wrong and the second.
Yes, Jareen, come up with the answer.
Sir, is it the option D, sir?
Let's see, let's see. Paritosh, what do you say?
I think so. It's I don't know, maybe a statement. I got the statement once correct.
So answer would be, can be. चलिए, okay, Charvi.
Sir, D.
Okay, first statement देखिए, temperature contrast between continents and ocean is greater during summers than in winters. Just now we have seen, okay, that contrast is higher in winters. So very straightforward, this becomes incorrect statement. Specific heat of water is more than that of land surface. This is correct statement. We have seen the comparison also, 4.18 joules per gram per degree Celsius for water. Okay, higher. So this one is correct statement. So D becomes correct statement over here. This is 2013, the question which was asked. Then 2014, they repeated the question. And now if you check this question, which of the following are correct inferences from isothermal map in the month of January? They are asking us about January isotherm. Isotherm deviate to the north over ocean and to the south over the continents. Presence of cold ocean currents, Gulf Stream and North Atlantic drift makes the North Atlantic Ocean colder and the isotherms bend towards north.
So first statement wrong.
Second is
Okay.
warm ocean current.
The first statement is correct. And
Okay.
second one is wrong.
Everyone try to figure out. See, that's the purpose of the class, na, कि सबको बनना चाहिए. This is not a general class. Take your time. Okay, try to figure out the answer.
So Gulf Stream is a warm ocean current. So
As of now, don't explain anything. Okay, just the answer. If you have found the answer, just
Option
type
A.
it in the chat box
okay.
so that I can see. Then we will discuss it.
One only is correct.
So option 1 is correct.
Just type the answer in the chat box. I'm reading it. Okay, the first statement. January isotherm, the isotherm deviates to the north over the ocean and south over continents. Correct statement? Yes, correct statement. Over the land, we have seen the rule, January southward deviation. So this first statement is correct. Second, presence of cold ocean currents, Gulf Stream and North Atlantic drift makes the North Atlantic Ocean colder and the isotherm bend towards north. Now in this case, this second part is correct. Isotherm bend towards north, this is okay. No problem in this. Just now we have seen the isothermal map. But making the ocean colder makes no sense. Gulf Stream, North Atlantic drift is a warm ocean current anyways. And if the ocean became colder, there was no question of this bending towards north. It goes against our rule. Just now we have seen the rule. Warmer, then only the isotherm have bent towards that particular part. Yes, everyone got it?
Yes, sir.
So in this case, this statement becomes wrong and your answer becomes 1 only. So this is the concept of isotherm and the related aspects of deviations, variations, spacing, different characteristics. The topic isotherms.